Hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW Gulf. Students, I welcome you all to your Triumph Ultimate Recap session. And what are we going to do today, ma'am? Today, we are going to cover with our chapter that is haloalkanes and haloarenes. Now students, as I was saying that this is basically your ultimate recap session. That means we are going to cover the complete chapter, complete haloalkanes and haloarenes in your this session, okay? In your ultimate recap session. Ultimate recap, it's itself a revision kind of a session, yes? So I guess you all have already done this chapter, but now it's turn to, revise it with the help of flowcharts and with the help of some of the important key highlights. Yes, everyone? Okay. So, let's start with this particular session today. Now, students, what is today's target? What are we going to cover in this particular session? So, first of all, I will be letting you know about the introduction part. And in introduction, I'll let you know all the, part of nomenclature, classification, with regard to haloalkanes and haloarenes. The second part, students, that we shall be discussing will be all about haloalkanes in detail. Now, when I'm saying haloalkanes in detail, it basically is going to include the methods of preparation. It is going to include the methods of preparation, its physical properties and the chemical one. Physical and the chemical one. So, all of these segments will be covered with regard to the haloalkanes part. And the next part will be about haloarenes, everyone. It will be all about haloarenes. In the same way, we are going to understand about methods of preparation, its physical properties, its chemical properties. Yes, clear? Okay, that's great. Now, we are going to start with the general method of preparation of alkyl halides, and I am going to proceed with your alcohol. How with the help of alcohol you can prepare your alkyl halides, I would say, or I would say haloalkanes. But see students, this is the topic that is the most important one. This is the topic that is the most important one, methods of preparation and the chemical one. In the same way for haloarenes also it is going to be the most important one. So I feel that yes, you all have already done with the classification and nomenclature. Though I'll give you a very short intro about it, and then I'll come back to this part because it is very, very important. Yes, so now first of all let me introduce you to haloalkanes and haloarenes. I guess everybody very well know what are haloalkanes. Yes. When you're going to remove one hydrogen atom from any hydrocarbon, especially alkane, and you're going to attach any of the, halogen group, that creates your haloalkane. For example, if we have CH4 and I'm going to remove one hydrogen and I'm adding one halogen over here, this basically is what? This basically is your haloalkane obtained. This basically is a haloalkane obtained, and in other words, it is also referred to as alkyl halide. What it is referred to as, ma'am? Alkyl halide. So, okay, if I'll talk about what is haloarenes, what is haloarenes, everyone? So you will say halo again refers to halogen atom, and arenes, that means now in an aromatic compound, if you are going to remove one of the hydrogen atom and you are going to attach one of the chlorine or bromine or fluorine or iodine, that means you are going to attach one of the halogen atom, it creates your haloarenes. Let's take an example. If this is my aromatic ring and now I am going to remove one hydrogen, I am going to add one halogen. So we very well know each and every carbon has a valency of 4. So here is one hydrogen attached at each carbon atom. That means if one hydrogen is being removed and one halogen atom is being attached, okay, or I would say one hydrogen atom is replaced by an halogen atom, it creates your haloarenes. It creates what, ma'am? It creates your haloarenes. This is basically the haloarenes. This is basically the haloalkane. Other words of haloalkane is alkyl halide, and other word for haloarene is aryl halide. Always remember, halogen that you can use over here can be fluorine, chlorine, bromine, iodine, and so on. Now students, let's discuss about the IUPAC part, that means the nomenclature part. Now in IUPAC part, if you have observed that we have uploaded a complete session of IUPAC of class 11th standard. If you don't know how to do the nomenclature, you can go through that session. Again, it is on PW Gulf channel itself, only on the YouTube. You can just see the IUPAC complete session and you can cover a lot of questions from that part. Still, I'll explain you a general basic formula with the help of which you can do the nomenclature for haloalkanes and haloarenes. First of all, you should know for an IUPAC nomenclature at the centermost position you need to write word root. Now students, word root is going to indicate that how many carbon atoms are present in a parent chain. Okay, this is what is the significance of a word root. If we have one carbon atom, it indicates meth. If we have two carbon atoms in the parent chain, it indicates it. If we have three, it's prop. For four, it's but. For five, it's pent. For six, it's hex. For 7, it's hept. For 8, it's oct. For 9, it's non. For 10, it's dec. For 11, undec. And for 12 is dudec. I guess this you very well know. If you don't know, again repeating on this YouTube channel only, that is PW Gulf, you have a session of IUPAC part. Go there, check the video. You will be able to solve all the questions. Now coming back to this only, when I was talking about IUPAC, let's see the word root. Word root represents number of carbon atom in the parent chain. At the right hand side position, we have primary suffix everyone. Primary suffix indicates the type of bond between carbon-carbon. If there is a single bond between carbon and carbon, you are going to use ANE. If it is a double bond, ene, triple bond, ine. Okay. After primary suffix, you are going to write secondary suffix. Now, secondary suffix is used for senior most functional groups. Now, if only one functional group is present, you need to place it at secondary suffix. But if more than one functional group is present, you can assign them as a junior most functional group position and as a senior most one. So, senior most will be given the place of secondary suffix and the junior most will be given the place of secondary prefix. Clear? So, now, before word root, students, you need to write primary prefix, which indicates, which is generally used for cyclic compounds, and the word that you're going to use is cyclo in this case. Okay. At last is secondary prefix, which is used for junior most functional group, which is used for side chain, for extra group. The halogens that you're going to use, you're going to place it over here. When there is an halogen in a compound, you are going to place them at secondary prefix. That means if you have fluorine attached somewhere, you are going to use secondary prefix as fluoro. If chlorine is there, you are going to write chloro. If bromine is there, you will write bromo. Iodine is there, you will write iodo, in such a way. Clear, everyone? I'll still mention each and every key point that I've explained you. Word root represents total number of carbon atoms in a parent chain, okay. Primary suffix represents bond between carbon and carbon. If carbon-carbon contains a single bond, it is ane. If carbon-carbon contains a double bond, it's ene. If carbon-carbon contains a triple bond, it's ine basically. Let's now talk about secondary suffix. So this is used for senior most functional group. If I talk about primary prefix, used for cyclic compounds, and you're going to write cyclo for that case. Coming to secondary prefix, used for junior most functional group, for extra groups, for side chain. Let's take few examples of the IUPAC part and then we shall proceed further, students. So if I'll take few examples, let's take the very first example. If I'm going to write CH3, CH, CH3, CH, Cl, CH, Br, CH3. For example, you have been given this compound. So how you need to do the naming? You're going to start with 1, 2, 3, 4 and 5 carbon atoms. When there are 5 carbon atoms in the main chain, in the parent chain, you are going to write word root as pent. What are you going to write? Pent, ma'am. When there is a single bond between carbon and carbon atoms, you are going to write ane. You are going to write what, ma'am? Ane. Okay. Extremely sorry, students. Coming back. For word root, you are going to write pent. Now, for single bond between carbon and carbon, primary suffix is going to be ane. Now comes, secondary suffix. There is no functional group, so no secondary suffix will be used. Now, we have as an extra group, we have CH3, for which we are going to write methyl. For Cl, we are going to write chloro. For Br, we are going to write bromo. So, how we need to mention? As per ABCD, B comes first and it is present on the second carbon atom. So, the name is 2-bromo, 2-bromo, dash. Now, chlorine will come. So, it's 3-chloro. Let me first erase it. Yeah. So, the next is going to be 4-methyl pentane. So by this way, you can easily do the nomenclature part. I guess nomenclature part you very well know, everyone. Is it clear? Shall I move on to the next page? I guess this is so clear to each and every one of you. Okay, taking few more examples over here. For example, students, I have this case. Now see, again the numbering is going to start from a 1, 2, 3, 4, 5 and 6. For 6 carbon atom, the word root is going to be hex. Now there is a double bond between the second and the third carbon atom. So you need to write the smallest number, that is second, and for double bond we write ene as a primary suffix. Now there is no functional group, so no secondary suffix will be written. Now primary prefix will also be nothing because it is an open chain compound, not a closed chain one. Now for CH3 we are going to use methyl. Yes, and for Cl, we usually write chloro. So as per ABCD, C comes first. So we are going to write 3 dash chloro 4 dash methyl hex 2 ene. Is it clear to each and every one of you? Now let's take one more example and then we'll proceed to the next part. For example, students, I have this case over here. Now see, in this particular case, this is going to be my first carbon, my second, third and fourth carbon. Now for 4 carbon atoms, the word root is going to be but. Now there is no double bond or a triple bond present between carbon and carbon. All contains a single bond. So you are going to write butane over here. But now comes secondary suffix. You can clearly observe, everyone, you can clearly observe COH group, which is basically used for carboxylic acid. And whensoever you will observe carboxylic acid, the secondary suffix for carboxylic acid basically is what is your oic acid. Is what, ma'am? Is your oic acid. And when you are going to name it over here, students, remember butane ends with E, oic acid starts with O. Two vowels cannot be together, so you can just erase this E. And now it will be butane. It is present on first carbon, so it's oic acid. See, if you know carboxylic acid carbon is included in the parent chain, you're going to write oic acid. But if it is not included, you're going to directly write carboxylic acid. I guess this is so clear to each and every one of you. Now we have a chlorine group attached to the second carbon, so this comes out to be 2-chloro. Butane 1 oic acid. I guess nomenclature part is so clear to each and every one of you. Now students, I am going to proceed with the next part of yours, that is going to be the classification. So we can classify, haloalkanes basically on the category of the hybridization, on the category of number of halogen atoms present, on the category of degree of carbon. So by 3 ways we can do the classification. The very first way is number of halogen atom present. Number of halogen atom present. So this is the first way how we can classify them. Let's start with the very first part. Depending upon the number of halogen atom present, it can be classified as mono haloalkane. Mono haloalkane. The next one is going to be dihaloalkane. Dihaloalkane, and the third one is trihaloalkane. Clear? Now see, one more thing students, you should know that dihaloalkane is further categorized into 2 types. One is vicinal dihalide. One is vicinal dihalide. Another one is gem dihalide or geminal dihalide. This is now based upon the number of halogen atoms present in a particular compound. Okay, let's start with the very first part, that is monohaloalkanes. Let's start with the very first part, that is monohaloalkanes. Now see students, if only one carbon atom is present in a, if only one halogen atom is present in a compound, that creates a monohaloalkane. When only one halogen atom, when only one halogen atom is present in a compound, that is monohaloalkane. You can take a general example. CH3, CH2Br. We have only one halogen atom bromine present, so this is monohaloalkane. Now let's see the next one, that is dihaloalkane. Dihaloalkane. If I'll talk about dihaloalkane, when two halogen atoms, are present in a compound, that creates basically your dihaloalkane. Okay, now they can also be further categorized as gem dihalides and vicinal dihalides. So what is gem dihalide? When both the halogen atoms when both the halogen atoms are present on same carbon atom, that is geminal dihalide or gem dihalide. Let's take an example. Now see, these both bromine groups are present on the centermost carbon atom, that means on the same carbon atom. So this creates your geminal dihalide or gem dihalide. The next case is vicinal dihalide or vicinal dihalide. Vis dihalide or vicinal? When both the halogen atoms, are present on adjacent carbon atom, that creates your vis dihalide or vicinal dihalide. Let's take an example. See, bromine groups are present on the adjacent carbon atom, so this creates a vicinal dihalide. Geminal is one when they are present on the same carbon atoms. So this is the very first classification. What will be trihaloalkane? When there is three halogen atoms present in a compound. Yes. So what is trihaloalkane? What is a trihaloalkane? When three halogen atoms are present in a organic compound. Let's take an example. So this is a case of trihaloalkane. Clear everyone? This was the very first classification. Now we shall start the next classification based upon degree of carbon. Based upon degree of carbon, now students, it can be classified as primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. What is the primary alkyl halide? When halogen atom is attached to primary carbon, that creates a primary alkyl halide. Let's take an example. CH3 CH2Br. Now see, bromine is attached to this carbon, which is further attached to only one carbon. That means this carbon is a primary carbon to which bromine is attached. So this alkyl halide is primary alkyl halide. Now what is the secondary alkyl halide? When halogen atom is attached with secondary carbon or 2-degree carbon, that creates a secondary alkyl halide. Let's take an example. See, this bromine is attached to this carbon, which is further linked with only 2 carbons. So this is a secondary carbon to which bromine is attached. Hence, this is secondary alkyl halide. Now comes tertiary alkyl halide, when halogen atom is attached with 3-degree carbon or tertiary carbon, that is tertiary alkyl halide. Example is, now this bromine is attached to a carbon which is further linked with 3 carbons. So this basically creates a tertiary alkyl halide. Clear everyone? So this is now the classification that is basically based upon the degree of carbon atoms. Clear? Okay. Now students, here comes the next part, that is based on hybridization. Based upon the hybridization. Let's see, the very first basically is your vinylic halide. When halogen atom is attached to sp2 hybridized carbon atom, which itself creates a double bond. Let's take an example, everyone. For example, this halogen atom is attached to a carbon which itself creates a double bond. So this is basically the vinylic halide. You can fulfill the valency of carbon atoms with the hydrogen atoms. Yes. Now comes the next part. This is about vinylic halide. Second is allylic halide. When halogen atom is attached with sp3 hybridized carbon atom, which is connected to a carbon atom, which is further connected to a carbon atom, that creates double bond. Let me show how, students. For example, this halogen atom is attached to a carbon which is further linked with a doubly bonded carbon. So this is allylic halide. Clear everyone? Okay. Now students, comes the next two categories of this one only. That is basically your aryl halide. So when halogen atom is directly attached to benzene ring, that is basically your aryl halide. Let's take an example. This is basically an example of aryl halide. When, in other words, aryl halide is also known as haloarine, everyone. Simple. Now comes the next part, that is benzylic halide. When halogen atom is attached to a carbon which is further linked with benzene ring. When halogen atom is attached with a carbon which is further linked with, attached to benzene ring. That is basically the benzylic halide. For example, this is your halogen attached to a carbon which is further linked with the benzene ring. So this is benzylic halide. Students, this was all about the classification. Now we are going to start with the methods of preparation of whom? First of all, the alkyl halides, or I would say the haloalkanes. So when you're going to start from alcohols, it is very easy reactions that you're going to see with the help of alcohol. Alcohol is ROH. What alcohol is, ma'am? It is ROH. How you're going to proceed is, see, if you're going to take, concentrated HCl and anhydrous ZnCl2. Let's take an example of this one also. If you're taking this part, okay, concentrated HCl and anhydrous ZnCl2, see, this water will liberate out and what you will be left with RCl. Yes, so this is what is haloalkane. This is what is a haloalkane, the very first reaction. Yes, now there is further more reactions. If you're going to take HBr with H2SO4, again you are going to get what? Water will be taken out and RBr will be the final product. Clear with this part? Okay, ma'am. See, if students you are taking what? If you are taking HI, simple, again water will be removed and I will get attached with R. Ri will be formed. Now these reactions are very, very important. Let me show you how. For example, if you have alcohol ROH and you are reacting with PCl5, let's consider the case of PCl5. You can write PCl5 as PCl3, Cl and Cl everyone. Simple part, no? Just break the bonds. What are you going to get? You will get RCl, you will get HCl, you will get POCl3. So this is this one reaction, that when you are taking alcohol and you are reacting it with PCl5 in such a way, you are going to get the product. In the same way, students, if you are reacting with PCl3, then also you are going to get RCl. Now comes SOCl2, thionyl chloride. If you are going to take SOCl2, that is in the presence of pyridine, you are going to get pure RCl. This is the pure product obtained. Let me explain you how. Let me do this reaction also. For example, if you have ROH, you are reacting it with SOCl2, you are going to get RCl, you are going to get HCl and you are going to get SO2. Basically SO2 and HCl will liberate out and you will be left with pure RCl obtained over here. So these all are methods of preparation from alcohol, everyone, that you are taking alcohol and you are taking various reagents, you are going to obtain what? Haloalkanes. Is it clear to each and every one of you? Just take a minute, students, write each and everything that I have told you over here. Now comes the next part. There are few points, with regard to the preparation method that I have clearly mentioned over here. Now I am going to read you out and you are going to mark it as an important one because they are the major key highlights. I am going to tell you the important key points. The very first is, just I took you with HCl. I told you it's very simple. You are going to liberate water out. When you are going to take this part, remember what will happen. This OH in this hydrogen, water will be removed, and this Cl basically will get attached with this. You will get C2H5Cl. This is what I have told you in the previous part also. Next, anhydrous ZnCl2 that you are using over here is acting as a dehydrating agent. See, whensoever you will see a word De, that refers to as removal. Removal of what? Hydrating means water. That means removal of water. Now, the process of using the HCl gas and the anhydrous ZnCl2 is called Groves process. Now, many a times questions are directly asked from this, what is a Groves process? When you are taking HCl and anhydrous ZnCl2, that is basically the Groves process. Coming to the next part, we have pyridine, dimethylamine and concentrated sulfuric acid are also used as catalyst. You want to now see, basically for alcohols the order of reactivity is 3 degree, 2 degree and 1 degree more stable, and among the HX I would say it is HI, HBr, HCl, HF. Why? See, in the case of HI, I would say size is larger. If size is larger, then you can easily break this bond. Why? Because you'll provide a very less amount of energy. If size is small, it has a greater force of attraction. You have to provide a lot of energy. So basically, the order of reactivities, HI will have the higher reactivity because iodine can easily go apart because it has a larger size. Clear? Now, students, comes the next reaction that I have already told you about PCl3, PCl5, SOCl2. See, if I am going to take C2H5 and I am going to take PCl, I will again get what? RCl, that is C2H5Cl, and H3PO3 will be liberated. Now see, in the case of PCl5, we are taking what, ma'am? We are taking C2H5OH. Can I write it like this? Now PCl5 can be written as PCl3 and Cl3. Break the bond. Simple part. You will get what? You will get C2H5Cl. You will get POCl3. You will get HCl. See, this is the reaction that you are obtaining. This is the main reaction that you are obtaining. Now, in the next part in SOCl2, I already told you, that you are going to liberate SO2 gas and HCl gas. And over here, this is the pure product obtained. Pure product obtained because they will go in the air. Clear? SO2 is preferred over PCl3 and PCl5 because the byproducts are gas. That's why. and also we are getting the pure product, right? By the actions of red phosphorus with bromine or iodine or alcohol, you can also obtain your haloalkane. That means you are taking red phosphorus okay, with bromine or iodine. This reaction is also observed in question papers. Now next comes the reaction that alkyl bromide RBr. How can you obtain that? When you're going to react it with NaBr and H2SO4, you're going to obtain that. Clear with this part, everyone? That's great. Now students, comes the next method of preparation, that how you can obtain haloalkane. You can obtain that from hydrocarbons. Now hydrocarbons are alkenes, and alkynes, right? So we are going to start with the alkenes first of all. How? With the help of alkenes you can do so. Always remember, there is two rules that you can go through. One is Markovnikov's rule, another one is anti-Markovnikov's rule. Now what is Markovnikov rule and anti-Markovnikov rule? First of all, let me explain you that part. Markovnikov rule is that negative part goes to that doubly bonded carbon atom, that double bond carbon atom which has less number of hydrogen atom. That is what is the Markovnikov rule. Let us take an example. If I have CH3, CH double bond CH2. Let's take this example and I am taking HI. Always remember, in HI we have H positive and I negative. So this negative part will go to that doubly bonded carbon atom which has less number of hydrogen atoms. So it will go over here and this H will come over here, double bond will get broken up. You will get CH3, CHI. Here is also CH3. So this is the major product. How you obtained it? With the help of Markovnikov rule. Negative part will go to that doubly bonded carbon atom which has less number of hydrogen atom. I guess this is so clear to each and every one of you. This is what is written. If HX is added to an unsymmetrical alkene, that results in the formation of Markovnikov's product. This is the major product. This is the minor product. Major product with the help of Markovnikov. Now next comes basically what is anti-Markovnikov? Let me tell you that also. If in anti-Markovnikov rule, what you will see on the arrow, HBr with peroxide. If this is written, no, you have to do anti-Markovnikov. What is anti-Markovnikov? Just as opposite. In Markovnikov, we were adding, negative part to the less number, to the carbon atom which contains less number of hydrogen atom, no? But in anti-Markovnikov, the rule will be different. Negative part will now be added on to that carbon atom which has more hydrogen atoms. I guess this is clear to you. That is basically anti-Markovnikov rule. And it is seen and observed in HBr with peroxide only. Now comes the addition of halogens. See, Br2 when we are going to add it, it's very simple, students. You are going to obtain your vicinal product. You are going to obtain your vicinal dihalide. That means both of the bromine are going to attach on the adjacent carbon atom. This is addition of halogens. This is also another methods of preparation. Now comes some of the naming reactions with regard to the methods of preparation. The very first is Finkelstein reaction. What happens in Finkelstein reaction? We are going to take Rx. Okay, now we are going to take Rx in which X can be either chlorine or bromine. That means you have to take a chloride and a bromide halide only. Okay, and you are going to react it with sodium, if you'll see, it is iodide, that is NaI, in the presence of what? Dry acetone. What you will be obtain? Ri. You will get what? Alkyl iodide. So in order to prepare alkyl iodide, go with the reaction that is Finkelstein reaction. Okay, NaCl or NaBr formed is precipitated in dry acetone. That's why we are not taking it. We will take NaI over there. Clear? Now, the reaction follows which mechanism? SN2 mechanism. What is an SN2 mechanism? That is nucleophilic substitution. And 2 refers to bimolecular nucleophilic substitution. Okay. Now, this is one more reaction provided to you in order to obtain the alkyl fluoride. Now, students, these comes your somewhat, I would say, a method of preparation. These are basically your method of preparation. Now, this I will first explain you with the help of what? Firstly, we will explain these with the help of, we will understand these with the help of these 3 major reactions. That was all about methods of preparation. Coming to the chemical properties, let me tell you there are 3 major chemical properties that is in your syllabus. That is nucleophilic substitution reaction. Second is elimination, here reaction will come. Second is elimination reaction. Third is reaction with metals. Okay, so we are going to start with that. First of all, let me tell you about nucleophilic substitution reaction. See, SN reaction basically is categorized into 2 types. One is SN1, another one is SN2. SN1 is unimolecular. SN1 is unimolecular nucleophilic substitution reaction. And what is SN2? It is bimolecular. It is bimolecular nucleophilic substitution reaction. Now I just think that you people have already done the mechanism of that part. So I'm coming with regard to the competitive. I'll explain you the major highlights of SN2 and SN1. Let me tell you students, SN2 reaction, here back attack is possible. Here back attack is possible. Also here retention compound, sorry, here inversion compound is obtained. Inversion compound is obtained. Moreover, SN2 reaction is a single step reaction. Here strong nucleophile is being observed. Okay, moreover, generally we are going to take aqueous NaOH only over here, right? A back attack is possible in this particular case. In SN1, I would say SN1, it is a two-step reaction. Okay, here racemic mixture is formed. Here racemic mixture is formed and front and back both attacks are possible. Here you have to take a weak nucleophile. One more thing, here carbocation is also formed. Carbocation is formed. So if I'll ask about the reactivity of SN1, it is 3 degree more stable, then 2 degree, then 1 degree. And if I'll ask you about the reactivity of SN2 everyone, it is 1 degree more stable, then 2 degree, then 3 degree. In general, what is SN reaction? For example, if you have RX and you are reacting it with a nucleophile, what will happen? This nucleophile will substitute X and will take its place like this. This is what is a nucleophilic substitution reaction. I guess this is so clear to each and every one of you. Yes. Now students, I am showing you a flow chart for all the chemical reactions everyone. These are all the chemical reactions of alkyl halide. These are chemical reaction. See, if you are reacting RX with aqueous NaOH, now only I told you aqueous NaOH, that means it is acid2 reaction. OH negative will come and will take place of X. It will substitute it and ROH will be formed, liberating what? What is the byproduct, ma'am? NaX will be liberated out. What else if we have? If we have H positive, OH negative, this OH negative will go and take the place of X. You will get ROH and water will be liberated out. Simple, easy reaction. Okay. Now students, if you are taking KCN, let's take the case you are taking KCN. Now see here. Here it is RX. Here you are taking KCN. So it's R positive, X negative, K positive, Cn negative. So RCN will be formed and Kx will be liberated out. This is for the ionic product. Now when we have an AgCN, that is a covalent compound, you will obtain RNC. Now in the same way for AgNO2, if you are going to take, you are going to get RNO2. But if you are going to take KNO2, you will get RONO. Because NO2 and CN, they both are ambidentate ligand. Okay everyone. Next comes RMGX. Okay, if you are reacting RMGX with RX, you are going to get RR as the major product. Clear with this part? Now students, comes the next reaction, that is the next chemical property, that is beta elimination. This is basically the elimination reaction. And when you do the elimination reaction, you're going to get an alkene. Let me show you this reaction because it is very, very important. So I'm showing you this reaction separately. Okay, let me show you this reaction separately. For example, students, here I'm writing the elimination reaction. For example, you have CH3, CH double bond CH2. Let's take this, sorry. For example, students, you have this case, okay, and you are basically reacting in the presence of alcoholic KOH. See, when aqueous KOH is written, you have to go for nucleophilic substitution reaction, but when alcoholic KOH is written, you have to go with beta elimination reaction. With which reaction, ma'am? With beta elimination reaction, which is also referred to as dehydrohalogenation reaction. Which reaction, ma'am? Dehydrohalogenation reaction. Now, what you need to do over here is dehydrohalogenation. De refers to removal. Hydro refers to hydrogen, halogenation refers to halogen. That means you're going to remove HX. Chlorine from here and one hydrogen from here will be removed and a double bond will come over here. So you will get CH3C H double bond CH2. So an alkene is obtained in this as a major product. Always remember, if you are taking aqueous KOH or aqueous NaOH over here, students, you will go for nucleophilic substitution reaction. But if you are writing alcoholic KOH, you will get an alkene over here. Clear with this part? Now clear with this part? Yes. And there is also one more reaction, that is preparation of Grignard reagent. RMgX is the Grignard reagent. This is basically the Grignard reagent. So basically, when you are reacting Rx with dry ether and Mg, you will obtain Grignard reagent, which on further reaction will give you again Rx. Clear with this part, everyone? Okay. Now, students, comes the, the preparation of haloarenes. Now, haloarenes is something when I can say that benzene ring contains a halogen atom or aryl, I would say halide. Now, let me tell you first of all what it is. This is basically diazonium salt. And how you will obtain first this? See, you can obtain this with the help of aniline. What is aniline? This is aniline. Benzene ring containing NH2 group. Okay. So, when you are taking aniline and you are reacting it with NO2NHCl, you will get this diazonium salt, which on further reaction with CuBr will give you alkyl bromide, which on reaction with CuCl will give you alkyl chloride, which on reaction with Ki will give you alkyl iodide, and which on reaction with HbF4 will give you alkyl fluoride. So all of these are methods of preparation of haloarenes. First, you need to prepare diazonium salt with the help of aniline. Another method is, if you are taking a benzene ring and you are reacting it with Cl2 and Fe and FeCl3 in dark and cold condition. In dark and cold condition, you are going to obtain your haloarene over here. Haloarene over here. Clear with this part? Okay, now students, this is the types. These are few points which I have written for nucleophilic substitution reaction, which you should know. So it is of SN1 and SN2 type, though, which I have already explained you. Nucleophilic substitution depends upon which of the following characteristics: structure of alkyl halide, reactivity and structure, concentration, and the solvent in which it is being carried out. Clear? I told you, there is a strong nucleophile, there is a weak nucleophile. That is what is written over there. Clear with this part, everyone? Now, students, come some properties of haloarenes. See, physical properties, if I'll talk about haloalkanes, again, physical properties, you need to keep in mind the two major products for alkanes, if I'll talk about. For haloalkanes, if I'll talk about, so it depends upon the boiling point factor, that it is directly proportional to molecular mass. Secondly, it is inversely proportional to branching. Main is this one only. Main factor is this one. Other than this, there are some factors for, I would say, for haloarenes, like alkyl halides. Aryl halides are insoluble in water due to their inability to form hydrogen bond. Okay, haloalkanes can dissolve because they have hydrogen, but they do not have. They are insoluble in water. So this is one of the physical property. Next, aryl halides are less polar than the alkyl halides. Okay, because of the hybridization. Next, the electronegativity difference between carbon and chlorine is low in aryl halides than in alkyl one. Okay. The next is possibility of resonance of chlorobenzene makes carbon Cl bond shorter. These are few things that you should know, everyone. Clear? And then the next one, important one, you can put a star mark over here. The para isomer has higher melting point than the ortho and the meta isomer. This is due to the symmetrical structure. So they can give you meta product, ortho product, and a para. Para will have the highest melting point. Clear, everyone? Now this is what they have shown you the structure. This is basically the para one, so it will have the highest one. Then it will be the ortho one, and at last it will be the meta one. Okay, clear, everyone? And this is the boiling point of the I would say isomeric dihalobenzenes. Clear? Clear, you can easily write all of these points over here, which has higher melting point, which has a lower melting point. Now students, comes the last part, that is the chemical properties of haloarenes. Now comes the last part, that is chemical properties of haloarenes. See, basically, if you have this as your haloarene and you are reacting it with concentrated HNO3 with concentrated H2SO4, what you will obtain over here? It's very simple, students. You will obtain which kind of a product over here? These two products will be obtained over here. This is a para-directing product and this is a ortho-directing. This is electrophilic addition reaction. Electrophile is NO2 when you are taking HNO3. Okay. If you are taking CH3Cl over here with anhydrous AlCl3, you will get one CH3 at the ortho position and another CH3 at the para position. If you are taking concentrated H2SO4 twice, you will obtain what? SO3H at the ortho position and SO3H group at the para position. Yes, everyone, it is so clear to each and every one of you. So these are some kinds of reaction that are generally observed. If I'll take an example of Friedel-Crafts acylation, alkylation I have already given CH3Cl. If I'll take this example, CH3C double bond OCl, this is acylation 1. So what are you going to get? You will get this as your ortho product and this as your para product. Clear with this part, students? So these are some chemical properties that I would say with regard to haloarenes. Everyone just write it down so that now we can just end up with the session. One more thing we can do is, when we are taking two molecules of haloarenes and we are taking sodium, okay, 2 sodium with dry ether. Remember what is going to happen. This is basically the Fittig reaction. 2 Na will combine with 2 Cl, you will get NaCl. And these two benzenes will join together. You will get a biphenyl ring. This is a Fittig reaction. This is which kind of a reaction, ma'am? This is Fittig reaction. Now, one of the chemical property of haloalkane was left, that when you are going to take 2 Rx with 2 Na in the presence of dry ether, this is basically your Woods reaction. Woods reaction, in which what is going to happen next, ma'am? 2 Na will combine with 2X, you will get 2 NaX and 2 RR is going to combine. The last reaction now comes is Woods-Fittig reaction. In this you are going to take 1 Rx and another haloarene. 1 haloalkane and 1 haloarenes, and you are going to take 2 Na. So basically 2 Na will combine with 2X and you are going to get this as your final product. Clear with this part, everyone? Okay. So, thank you so much, my dear students. Now we are ending our today's session over here. I hope so you have, already revised this particular chapter. If not, students, this complete session will cover each and everything from methods of preparation, IUPAC, classification, physical properties and chemical properties. But what is your work? Your work is to listen to the session first and then to revise your notes and then further apply them on the question part. Because before, if you're not going to apply it on question, you're not going to analyze yourself that whether you know that topic or not. So by today, students, just see the video, understand the concept and then apply on the question and do your self-analysis and check out that which topic of yours need to be more practice. So thank you so much, my dear students. Now we shall be meeting in the next class. Till then, keep smiling, keep learning. Thank you so much and take care, everyone.